Okay, if you just listened to the reading, we learned about all the different types of scales that you can use to describe an earthquake. So what we're going to do in this video is take that information and put it into our notebook. So now we've started section 19.3, and this first part was all about earthquake scales. A little bit of vocabulary first. The first scale that we read about is known as the Richter scale, and this is the one that everybody thinks that we use. When you hear about earthquakes on the news and you hear the number on the Richter scale, most people know that 8 is pretty high on the Richter scale, and numbers that are smaller are lower on the Richter scale. This is a numbered system, so starting with 1 at the bottom and then working its way up, a numbered system of the energy released by the largest waves of an earthquake. So it measures the energy released by the largest waves. So to understand what each of these scales is talking about measuring, we also need to understand a couple of other vocabulary words in regards to earthquake waves. So the first one of those is magnitude. Magnitude is another word for energy of the largest earthquake waves. So when we talk about the magnitude, we're talking about how much energy has been released by the biggest of those waves. Another word that we need to understand the meaning of is amplitude. Amplitude is the height of the wave on a seismogram. And this is what they use to determine the Richter number. They use the amplitude of the wave. So let's draw a little picture here. If you remember what our seismogram looked like, it almost looked like a little graph. And then we had the earthquake wave. Let's switch colors for this. The earthquake wave is where the pen was going back and forth, kind of like that. The amplitude is the height of the biggest wave from the 0 point. So this is our tallest wave right here. The height from that spot down to the 0 spot, down to where the needle started or the pen started, that is the amplitude, the height of the wave. Alright, so the Richter scale measures the largest amount of energy that's released by the earthquake. And let's put one more little bullet note here about the Richter scale. The steps on the Richter scale increase in amplitude by a factor of 10 and energy by a factor of 32. So if you were thinking about this little graph, a step of Richter scale 7 versus Richter scale 8, that means that wave is 10 times taller and it's releasing 32 times the amount of energy. So one step on the Richter scale is a substantially larger earthquake event. might just sound like one step, but it actually means a lot more energy is released. Okay, so what is more common for us to use today? Most of the time, even though the numbers they give you on the news sound like they're Richter scale numbers, they're actually numbers on what's called the moment magnitude scale. So this is kind of like the Richter scale in that it still measures energy, but it takes a couple of other things into account. So let's first put down that comparison. The numbers sound like the Richter scale when you read things in the news or you see things online. And that's because it still measures the energy released. Still measures energy released by the earthquake, but also factors in the size of the fault rupture, the amount of movement and the rock's stiffness. So it still measures the energy that's released, but there are other factors that go into it to help determine what number that earthquake is going to be given. The last scale that we talked about in this section was the modified Mercalli scale. And this scale is a little bit different. It measures something called intensity, which is basically the damage that the earthquake creates. So it measures the intensity or the damage caused by the earthquake. It uses Roman numerals instead of regular numbers. If they both used regular numbers, it could get really confusing. So the modified Mercalli scale uses Roman numerals. And if you think about it, there's a couple of instances where the modified Mercalli scale would not be very helpful. If you have an earthquake that takes place in the middle of nowhere, there's not going to be a whole lot of damage. The less people, the less buildings, the less damage you're going to see, the less eyewitness accounts you're going to have. So you can't really use the modified Mercalli scale as well in a rural area as you can in a more urban area. It's also not very helpful for more historical earthquakes if we're trying to look back and put a measure of intensity on an earthquake that happened a long time ago. Again, the lack of eyewitness accounts, lack of structures or buildings to be damaged, those types of events are not going to be as represented as well by the Mercalli scale because there's just not as much to damage there. So we've got a little bit more notes about that intensity factor. So what is intensity and how do we decide what that means in terms of earthquakes? But we're almost done. The last little bit. What is intensity? When we talk about the intensity of the earthquake, we're basically talking about how much damage it causes. Intensity is pretty much how much damage is involved. But the intensity depends on the amplitude of the surface waves. The larger the surface wave, the more damage is going to be caused. It's the surface waves that do the most damage. And of course, maximum intensity is going to occur at the epicenter of the earthquake. Maximum intensity occurs at the epicenter. And just a quick little reminder here. Remember, we learned this vocabulary word already, but the epicenter is on the surface. And the focus is below ground. So the focus is where the earthquake actually originates from. The epicenter is the spot that's on the surface directly above the focus. So the intensity of the earthquake then also depends on the depth of the focus. The focus can be described as shallow, which means it's close to the surface, intermediate, which is kind of in the middle, or deep, and that would be pretty far underground. The ones that are going to be the most destructive are the shallow focus events. Shallow events cause more damage. The closer the earthquake is to the surface, the more damage you're going to get at the surface. All right, that's it for today. Hope you're keeping up with your notebooks at home.